So, I've heard some theories, but most of us haven't quite nailed it yet. And that's because you're a little bit unfamiliar with how to use equations, but that's okay, and particularly how to manipulate this equation. Before we go any further, let's just look at what we know. When we look at this triangle, what do we know? It's a 90-degree angle, so I know I can use trig or Pythag, correct? What do you think I should be using? Does it make any sense to use Pythag?
No.
Why does it make sense to use Pythag?
There's no angle.
Yeah, we want the angle, and we know that Pythag's really got not much to do with angles, so it makes far more sense to use trig. So yes, we do use trig. That's the first tip. More specifically in trig, what should I be using? Sine. Why should I use sine or sin?
Because you have the...
I have the hypotenuse and I have the opposite. So at this point in time, it's exactly the same. So my first line of working should be sine theta equals opposite over hypotenuse, correct?
Yeah.
What do you reckon I do now? Sub some values in. So, sine hasn't got a value, it's an operation. So I just write sine. Instead of writing theta, what should I write? X equals opposite, which is 9 divided by 12. Has anything changed about the process so far?
No.
Nothing's changed. And this is where the change is actually not about trig. What's it about? Rearranging. So what's the problem? What's stopping us right now? Because we want x by itself. What's stopping x from being by itself? The sign. So we need some button or some operation that's like the opposite of sine. Who reckons they can see it on their calculator?
Is it next? Sin -1.
Sine -1. So, what I'm going to do now is I'm going to cancel, I'm just give myself a bit more room. To cancel a sine, I use sine -1. And I do this to both sides, like I do with everything else. Now with sine, any sine, what do we need to make sure we've got?
Brackets.
Brackets.
What
What happens to the sines on this side? Why do we do the sine -1? What do we want to do? We want to cancel. So now we're left with x equals sine -1, 9 over 12. And what do you get?
48.6.
48.6.
Did we want
48.59.
So, I'll be very quick, so I'll go through it again and we're looking for buttons on a calculator. The first thing I do is identify its trig, because I want the angle. So because it's got something to do with an angle, trig. I then label my sides. I know I've got the opposite, right? Opposite, and the hypotenuse. I then sum in those I pick my equation, sine theta equals over h. I sub my values in, and now rather than rearranging by dividing or timesing, I use what we call an inverse sine to get x by itself. So that's the big step there. The big difference here is I have an operation, sine -1, to get rid of sine. If this was cos, what do you reckon I'd use? If I was trying to get rid of tan, what would I use? Tan -1. We need to practice this. But that's the crux of it. Same process. The only thing is we're adding this to our tool belt of things that we can rearrange with. Does that make sense?
Yeah.
If it doesn't make sense, you need to let me know.
It does.
Cool. Let's give you another example. Let's have an example here. We'll give you 10 centimetres here. I'll give you x there, and I'll give you 5 centimetres there, and I want you to find the value for x.